Welcome to the peaceful space of sleep-friendly science, where tonight we journey to the outer solar system to ask why Saturn alone wears such a magnificent crown of cosmic ice. In our celestial neighborhood, Saturn is the undisputed jewel. Its rings are a spectacle of such serene beauty, they seem almost unreal. But why? What cosmic artistry granted Saturn this gift, while its giant siblings remain unadorned? Let us explore this mystery together, in the quiet of the night. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1: Saturn, the peerless jewel. Let your mind drift now, outwards from the gentle blue-white light of our home world. We are embarking on a long and quiet journey into the deep, cold country of our solar system. We glide past the red, dusty plains of Mars, and across the great asteroid-strewn river that separates the inner worlds from the outer. We swing by the colossal, stormy presence of Jupiter, a king in its own right, robed in clouds of cinnamon and cream. And then, as we travel further into the twilight of the sun's reach, a new light begins to grow in the darkness. It is not a star. It is a pale golden lamp, serene and steady. And as we draw closer, we see that it is adorned with something impossible, something that has no right to exist, yet hangs in the void with a grace that stills the soul. We have arrived at Saturn. Saturn is the peerless jewel of our solar system. It is the celestial monarch, and its rings are its crown. When Galileo first turned his primitive telescope upon it in 1610, the image was so strange, so blurry, that he thought the planet had ears or handles. He did not know what he was looking at, but he knew it was a world unlike any other. And even now, with the perfect crystalline images sent back by our robot emissaries, that sense of profound, dreamlike wonder remains. Let us float here in the silent darkness and simply gaze upon them. They are not solid. From this distance they appear as a vast, flat, shimmering disk of light, tilted at a jaunt angle, as if the planet has paused to listen to a whisper from the cosmos. It is a halo of impossible thinness. The rings stretch for hundreds of thousands of kilometers, a span so wide that it would nearly bridge the gap between the Earth and our moon. And yet, for most of their expanse, they are only a few tens of meters thick. If you were to build a scale model where the rings were the size of a football field, their thickness would be less than that of a single sheet of paper. What are they made of? They are a river of ice. A trillion billion tumbling snowballs, moonlets, and mountains of nearly pure crystalline water ice. Each particle, from the size of a dust mote to the size of a house, is a tiny individual moon, trapped in a perfect eternal orbit around its golden parent. They are the ghosts of comets and the shattered remains of moons, ground down over eons into a shimmering, glittering dust. They are a blizzard in slow motion, a storm of ice that has been raging in perfect silent order for millions of years. As we watch, we see the sunlight perform its magic upon them. The countless facets of the ice particles catch the distant sun's light and scatter it, turning the entire system into a disk of liquid light. From some angles, they are brighter than the planet itself, a breathtaking spectacle of reflected glory. And they are not a single, uniform sheet. They are a system of systems, a symphony of structure. We see the great, dark gaps like the silent pauses in a piece of music, where the gravitational nudges of moons have swept the region clean. We see the delicate, intricate patterns, the braids and waves and ripples, as if a celestial finger has been gently drawn through this cosmic sand painting. It is a structure of almost unbelievable complexity, a record of the quiet, gravitational conversations that have shaped this system for ages. This is Saturn, a world defined not by its own golden face, but by the impossible, ethereal, and majestic crown it wears. It is the undisputed queen of the solar system, and its existence forces a profound question upon us. We know there are other giants in our solar system: Jupiter, Uranus, Neptune. They are vast and powerful worlds in their own right. So where are their crowns? Why did Saturn alone receive this gift of such breathtaking beauty? Section 2: the gossamer ghosts. To answer this question, we must leave the peerless jewel behind, letting its shimmering luminous form recede in our mind's eye. Our journey must now take us to the other giants of our solar system, the celestial siblings of Saturn. For the great secret of the cosmos is not that they are without rings, but that their rings are of an entirely different character. They are not shouts of brilliant light, but faint, ethereal whispers. They are the gossamer ghosts of the outer solar system. Let us first journey back inwards towards the Sun, to meet the king of the planets, Jupiter. Here is a world of breathtaking power and fury, a colossal ball of gas wrapped in belts of swirling violent storms. Its great red spot is a hurricane larger than our entire Earth. It is a world of immense gravity, of crushing pressure, a bully and a protector in our cosmic neighborhood. And for centuries we believed it was a world without adornment. It seemed that this powerful king had no need for a crown. But in 1979, as our robotic emissary, the Voyager 1 spacecraft, flew past the giant planet, it turned its camera around to take a final parting photograph. It looked back at Jupiter from its shadow side, with the distant sun backlighting the scene. And there, in that perfect alignment of light and shadow, it saw something no one had ever seen before. A faint ethereal glow. A halo. Jupiter had rings after all, but they were made of entirely different stuff. This was not a river of glittering ice. This was a ring of fine dark dust, like a puff of smoke from a celestial cigar. The main ring is thought to be made of dust kicked up from the surfaces of Jupiter's tiny, inner moons, Métis and Adrastea, by the constant bombardment of micrometeorites. It is a ring of debris, a halo of its own shattered children. It is so faint, so dark, that it is completely invisible from Earth. It only reveals itself when backlit by the sun, a ghost that can only be seen when it is standing in front of a distant candle. Now let us travel far outwards past the orbit of Saturn, to the strange and lonely worlds of the ice giants. Our first stop is Uranus, a world of quiet peculiarity, a pale blue-green marble, tipped over on its side as if it were knocked into a deep slumber billions of years ago. Here too we thought there was nothing, but in 1977, astronomers made a discovery of beautiful subtlety. They were not looking at Uranus itself, but were planning to watch it pass in front of a distant star, an event called a stellar occultation. And as they watched, just before the planet itself blocked the starlight, the star winked out for a fraction of a second. And then it winked again, and again, and again. And after the planet had passed, the same thing happened on the other side. They had not seen the rings. They had seen their shadow. They had discovered a system of at least 9 narrow and incredibly dark rings. If Saturn's rings are a broad, shimmering highway of light, Uranus's rings are thin black threads, like strands of soot drawn on a piece of velvet. They are among the darkest objects in our solar system, their particles as black as coal. They are thought to be made not of bright ice, but of rock and dust, perhaps the ground-up remains of a small carbon-rich moon. They are ghosts of a different kind, not faint because they are thin, but faint because they are black, swallowing the sunlight that Saturn's rings so brilliantly reflect. Our final stop on this tour of the ghost rings is the last great outpost of our solar system, the deep, windswept, sapphire blue world of Neptune. And here we find the strangest rings of all. Like those of Uranus, they are dark and thin, but they are not uniform. They are clumpy, uneven, and broken. The outermost ring is not a complete circle at all, but a series of distinct bright arcs, as if a celestial artist had begun to sketch a ring and then abandoned the work, leaving only a few brilliant strokes behind. For a long time this was a profound puzzle. A broken ring should not be stable. Its particles should spread out evenly in a matter of years. The current belief is that the tiny, unseen gravitational influence of a small, nearby moon may be acting as a shepherd, corralling the dust particles, holding them together in these fragile luminous arcs. So the mystery deepens. All the giant planets have rings. They are a common feature of these great worlds. but they are specters, gossamer ghosts, rings of dust and darkness. And so our question must be refined. The true mystery is not the absence of rings around the other giants. It is the overwhelming, breathtaking, and seemingly unique splendor of Saturn's. Why are they made of brilliant ice, while the others are made of dark dust? To answer that, we must first understand how a ring is born. Section 3: The Forbidden Zone. We have seen the peerless, icy jewel of Saturn and the gossamer, dusty ghosts that haunt its giant siblings. We now know that rings are a common feature of our solar system's great worlds. To understand why Saturns are so different, so uniquely magnificent, we must first ask a more fundamental question. Where do rings come from? How is such a structure, a disk of 1 trillion orbiting particles, ever born? The answer lies in a story of violence and destruction, a story of a force that is both a creator and a destroyer. To understand this force, we must first understand gravity not just as a gentle pull, but as a form of tension. Imagine a moon in a nice stable orbit around a giant planet. Let's make this moon a soft, loosely held together object, like a ball of dough. The planet's gravity is pulling on every single particle of that moon. But it is not pulling on all of them equally. The side of the moon that is facing the planet, the near side, is closer, and so it feels a slightly stronger gravitational pull than the moon's center. And the far side of the moon, facing away from the planet, feels a slightly weaker pull than the center. This difference in the gravitational pull across the body of the moon is called a tidal force. It creates a gentle, constant state of tension. It is the same force that our own moon exerts on the Earth, causing our oceans to bulge and creating our daily tides. For a moon in a distant, stable orbit, this tidal force is a gentle massage. It may stretch the moon slightly into an oblong shape, but the moon's own internal gravity, the force holding all of its own particles together, is easily strong enough to resist this gentle stretching. But what happens if our moon ventures closer to its parent planet? As it draws nearer, the tidal forces grow with astonishing speed. The difference between the pull on the near side and the far side becomes more and more extreme. The gentle massage becomes a powerful, relentless attempt to tear the moon apart. And at a certain critical distance from the planet, a line is crossed. Point of no return. At this distance, the tidal forces of the parent planet become stronger than the moon's own internal gravity that is holding it together. The gentle pull of the planet has become a violent, irresistible force of shredding. Any object held together only by its own gravity that crosses this line will be ripped to pieces. The ball of dough is stretched until it is torn apart into 1,000,000 tiny crumbs. This invisible, deadly boundary is known as the Roche limit. It is a forbidden zone that surrounds every large celestial body. It is a line drawn in the sky by the mathematics of gravity, and it is the place where rings are born. The Roche limit is not the same for every moon. A dense, rocky moon can venture much closer to its parent before it is destroyed than a light, fluffy, icy moon can. But the principle is the same. Inside this limit, large, solid moons cannot form, and existing moons cannot survive. Outside this limit, the moon's own gravity is king, and it can hold itself together as a single spherical body. The Roche limit is the line that separates the realm of moons from the realm of rings. So, we can now begin to imagine the birth of a ring system. Imagine a small icy moon, perhaps the size of a city or a small country, that has been orbiting its giant parent planet peacefully for billions of years. But something happens. The gentle gravitational nudge of a passing moon, or a subtle change in its own orbit, sends it on a slow inward spiral. It drifts closer and closer to its parent, and then it crosses the line. It enters the forbidden zone. The tidal forces seize it. The side facing the planet is pulled away with the violence that its own gravity can no longer resist. Cracks appear. The moon begins to stretch, to elongate, to come apart at the seams. And then, in a silent, slow motion, an utterly majestic act of celestial destruction, it disintegrates. It is torn into a cloud of 1 trillion billion pieces. But these pieces do not simply fly off into space. They are still trapped in orbit around the parent planet. Each individual piece of the shattered moon becomes a tiny moonlet in its own right, following its own new path. And over time, the countless gentle collisions between these particles will average out their orbits, smearing the initial cloud of debris into a vast, flat, and perfectly organized disk. A ring system has been born from the body of a dead moon. This is the great creative power of the Forbidden Zone. It is a place of destruction, yes, but it is also the ultimate cosmic ringmaker. Section 4. A Shattered Moon's Tale. We have now discovered the Forbidden Zone, the Roche limit, this invisible line in the sky where gravity ceases to be a gentle guide and becomes a merciless executioner. We have seen how this deadly boundary is the perfect cosmic artist, capable of shredding a moon and smearing its remains into a beautiful orbiting disk. This gives us a powerful and dramatic theory for the origin of Saturn's magnificent rings. It is the story of a lost, forgotten moon. Let's call this moon Chrysalis. Let us imagine this moon, Chrysalis, as it existed perhaps 100 million years ago. In the grand timescale of our 4.5 billion-year-old solar system, this is the very recent past. It is a time when the dinosaurs had already vanished from the Earth, and the age of mammals was well underway. In the heavens, Saturn may have been a different world. A world without its famous crown. It was still a beautiful golden giant, orbited by its great family of familiar moons by Titan, with its thick orange haze, by icy Enceladus and Rhea. And among them, orbiting peacefully between the paths of its siblings, was Chrysalis. Chrysalis was likely a moon of significant size, perhaps as large as Saturn's moon Mimas, a world a few hundred kilometers in diameter. And like so many of the moons in the outer solar system, it was made primarily of water ice. It was a great, cosmic snowball, a pristine and ancient worldlet that had likely been circling Saturn since the birth of the solar system. But its life was not destined to be a peaceful one. The outer solar system is a place of slow but powerful gravitational conversations. The great moons of Saturn are all in a constant, subtle dialogue, their gravitational fields gently nudging and pulling at one another. And over millions of years, these gentle nudges can add up. They can create resonances, instabilities. And according to this theory, Chrysalis was the victim of one such instability. Its orbit, once stable, began to drift. It was pushed slowly and inexorably inwards towards its colossal parent. Imagine the final days of this lost world. As it spiraled closer to Saturn, the golden giant would have swelled in its sky, growing from a beautiful, distant globe into a terrifying, world-filling presence. And as it drew nearer, it began to feel the strain. The tidal forces, the difference in gravity's pull on its near and far sides, began to stretch and deform it. Great cracks would have appeared across its icy surface. The quiet, frozen world would have begun to groan and shudder under the immense, invisible strain. And then it crossed the line. It breached the Roche limit. The moment was not loud, for there is no sound in the vacuum of space. It was a moment of silent, majestic, and utter annihilation. The tidal forces of Saturn overwhelmed the moon's own fragile gravity. Chrysalis was torn apart. It was not an explosion of fire and fury, but a gentle, irresistible shredding. The great icy moon dissolved into an orbiting cloud of its own constituent parts, countless billions of glittering icebergs, snowballs, and frost particles. The sacrifice of this single moon gave birth to a wonder. The newly liberated cloud of debris began to spread out, each piece finding its own new orbit. The larger chunks, in the chaos of the aftermath, would have collided with each other, shattering into ever smaller pieces. Over thousands and then millions of years, these countless collisions averaged out the orbits, smearing the initial chaotic cloud into the vast, thin, and exquisitely structured disk we see today. The brightest and most beautiful object in our solar system was born from the silent death of a single forgotten moon. This is the shattered moon's tale. And it is a story with compelling evidence to support it. Recent data from the Cassini spacecraft, which spent over a decade studying the Saturn system, has hinted that the rings are surprisingly young. They are not ancient relics from the birth of the solar system. Their pristine, bright ice is not yet heavily polluted by the constant rain of dark, micrometeorite dust from the outer solar system. They feel fresh. They feel new. Their age seems to be about 100 million years, perfectly matching the timeline for our lost moon's demise. The theory also elegantly explains Saturn's strange axial tilt. The planet is tilted by about 27 degrees, something that has long puzzled astronomers. The recent models suggest that the loss of a large moon like Chrysalis, and the subsequent gravitational interactions with the remaining moons and the distant planet Neptune, could have been the exact event needed to tip the giant planet over into its current, graceful inclination. The rings are not just a beautiful memorial to this lost moon. The very posture of Saturn itself may be a testament to its violent and creative past. Section 5. The Unformed and the Ancient. The tale of a shattered moon, of the lost world Chrysalis, is a beautiful, dramatic, and compelling story. It paints a picture of Saturn's rings as a recent and spectacular creation, a youthful jewel born from a celestial catastrophe. The evidence for their young age is strong, and this is now the leading theory. But in the quiet halls of science, a single compelling story is rarely the only one. And for a long time, another very different tale was told about the origin of these rings. It is a story not of destruction but of failed creation. It is the story of the unformed and the ancient. Let us travel back in time again, but much further this time. Not a mere 100 million years but 4.5 billion years to the very dawn of our solar system. The sun has just ignited, a young fierce star at the center of a vast spinning disk of gas and dust. This is the protoplanetary disk, the great cosmic nursery from which all the planets and moons will be born. In this disk, matter begins to clump together. Dust grains stick to other dust grains, forming pebbles. Pebbles collide to form rocks. Rocks merge to become planetesimals, the small city-sized building blocks of planets. And over millions of years, these planetesimals coalesce, their gravity sweeping up the remaining material, growing into the great worlds we know today. And around the newly formed giant planets, like Jupiter and Saturn, smaller versions of this process were unfolding. A mini-solar system was forming, a subdisk of gas, ice, and dust swirling around the young planet. And from this subdisk, the great families of moons were born. We see this today. The moons of Jupiter and Saturn orbit in a neat flat plane, all in the same direction, a clear echo of their birth in a single spinning disk. But what about the material that was too close to the young planet? What about the dust and ice that found itself orbiting inside the Roche limit? Inside that forbidden zone of tidal destruction? Here the story is different. The gentle force of gravity, which was pulling pebbles together in the outer parts of the disk to form moons, was overpowered by the violent, shredding tidal forces of the planet itself. Inside the Roche limit, creation was thwarted. Two ice particles might gently collide and try to stick together, but the tidal forces would immediately pull them apart again. A larger clump could never get started. The process of accretion, the patient building of a moon from smaller pieces, was permanently arrested. And so, according to this older theory, the material that was destined to become a moon or several moons was simply trapped in a state of eternal childhood, could never grow up. It was doomed to remain as a vast orbiting disk of its original constituent particles. In this view, the rings are not the remains of a destroyed world. They are the building blocks of a world that was never allowed to be born. They are primordial. They are as ancient as Saturn itself, a pristine, preserved sample of the original material from which the entire Saturnian system was formed. This theory has a quiet, simple elegance to it. It explains why rings are found around giant planets, because these are the worlds massive enough to have a significant Roche limit and to have once hosted a large circumplanetary disk. It positions the rings not as a sudden dramatic event, but as a gentle, persistent feature, a relic of the solar system's earliest days. So why has this beautiful primordial story fallen out of favor? The primary reason is the one we have already touched upon. The rings feel too young. A ring system that has been orbiting Saturn for 4.5 billion years should be dark and dirty. It should be polluted with trillions of tiny impacts from the dark, rocky dust that pervades the solar system. Over that immense timescale, the pristine, bright ice should have been coated with a layer of cosmic soot, turning the rings as dark as those of Uranus or Neptune. But Saturn's rings are more than 95% pure water ice. They are brilliantly, dazzlingly clean. They look new. And yet, the universe is a subtle and complex place. Perhaps there is a way to reconcile these two stories. Perhaps the rings are ancient, but there is some unknown, ongoing ring rain or recycling process that keeps them pristine. Or perhaps the truth is a mixture of both tales. The original rings may have been formed from this ancient, primordial material, but they have been replenished and brightened over the eons by the occasional destruction of a small, passing comet or an icy moon that strayed too close. The story of the rings may not be a single event, but a continuous cycle of destruction and renewal. For now, the evidence of youth favors the shattered moon. But the quiet, elegant story of the unformed moon remains a powerful counterpoint, a reminder that in the grand cosmic theater, there is often more than one way for a story to begin. Section 6. The Brilliance of Young Ice. We have explored the two great stories of the rings' origin: the dramatic tale of a recently shattered moon, and the more ancient tale of a moon that was never allowed to form. And while the evidence of their youth leans heavily towards the first story, both tales converge on a single crucial element, the one detail that truly separates Saturn from its giant siblings. It is the composition of the rings themselves. It is the secret of the ice. Let us return in our mind's eye to the gossamer ghosts that haunt the other giant planets. Jupiter's ring is a faint halo of fine dark dust, kicked up from rocky moons. The rings of Uranus and Neptune are threads of soot-black darkness, thought to be made of carbon-rich, rocky material. They are all rings of dust and stone. They are dark because they absorb the light of the sun. They are celestial shadows. Now let us turn back to Saturn, and we are greeted with a river of light. The difference is not just one of quantity but of quality. The particles that make up Saturn's rings are, to a staggering degree of purity, made of water ice. They are not rocky. They are not dusty. They are a blizzard of frozen crystalline water. And water ice is one of the most reflective substances in the solar system. Imagine a beam of sunlight traveling from our distant sun. When this light strikes a dark, rocky particle in the rings of Uranus, most of its energy is absorbed, converted into heat. Very little is reflected back for our eyes or our telescopes to see. The particle is like a piece of charcoal. It swallows the light. But when that same beam of sunlight strikes one of the trillions of tumbling ice crystals in Saturn's rings, the opposite happens. The ice acts like a brilliant tiny mirror. It reflects almost all of the light that strikes it. It does not swallow the light. It scatters it, it broadcasts it. It sends it glittering back out into the cosmos. Saturn's rings are not a shadow, they are a chandelier. They do not make their own light, but they are masters of borrowed light. Their brilliance is a testament to their pristine, icy nature. And this brings us back to the question of age. This dazzling whiteness is the strongest clue that the rings are young. Think of a fresh, clean snowfall here on Earth. It is a brilliant, blinding white. But leave that snow by the side of a road for a few weeks. It is slowly but surely polluted by the dust and grime of the world around it. It becomes gray, dark, and dirty. The same process is happening in space. The solar system is not a perfectly clean room. It is filled with a constant, thin rain of micrometeorite testiny particles of rock and dust, often originating from the dark, carbon-rich asteroids of the outer solar system. Over millions and billions of years, This cosmic dust settles on everything, and it is dark. A 4.5 billion-year-old ring system should be saturated with this dark material. Its bright ice should have been coated, sandblasted, and polluted into a dark sooty gray. The fact that Saturn's rings are still so brilliantly white is the cosmic equivalent of finding a freshly fallen field of snow in a world that has been running for billions of years. It tells us that the snow must have fallen recently. It tells us that the icy moon chrysalis must have been shattered in our solar system's very recent past, creating a fresh, clean, and dazzlingly bright field of debris that has not yet had time to get dirty. The brilliance of Saturn's rings is the brilliance of youth. It is the bright, shining face of a recent creation, a spectacle that may have only appeared in the heavens long after the dinosaurs had vanished from our own world. We are, it seems, living in a very special time in our solar system's history. A lucky moment when we get to witness this celestial jewel in its full youthful glory. This, then, is the heart of the answer to our great question. Saturn is not unique because it has rings. It is unique because its rings are made of ice. And they are made of ice because they were likely born from the destruction of a large, icy moon. And because that destruction happened relatively recently, the ice is still clean, the snow is still fresh, and the spectacle is still breathtaking. Section 7. The Sid of Ancient Rings. The brilliance of young ice. This is the secret to Saturn's peerless beauty. A recently shattered moon has gifted the golden planet with the crown of fresh, clean, and dazzlingly reflective water ice. The sheer splendor of the rings is a sign of their youth. And in this discovery we find the quiet, elegant solution to the other half of our mystery. If Saturn's rings are bright because they are young and icy, then the gossamer ghosts that haunt the other giant planets must be dark because they are ancient and rocky. Let us now return on our journey to the dark, thread-like rings of Uranus and Neptune. They are made not of glittering ice, but of a substance as black as coal. This darkness is their first great clue. It tells us that these rings are composed primarily of rock and carbonaceous dust, perhaps with a bit of dark, radiation-processed organic material mixed in. This is the stuff of asteroids, not of comets. This is the stuff of the inner, rockier parts of the solar system, not the icy outer realms. And their darkness is also a sign of their immense age. These are not fresh, clean fields of debris. These are ancient cosmic relics. They have been orbiting their parent planets for billions of years, for nearly the entire history of the solar system. And over those immense eons, they have been relentlessly weathered by the harsh environment of space. They have been bombarded by micrometeorites, their surfaces coated with a dark, sooty patina. They have been irradiated by the solar wind and cosmic rays, their chemistry altered, their once brighter surfaces darkened and aged. They are the cosmic equivalent of an ancient weathered stone, while Saturn's rings are freshly carved polished marble. But if these rings are ancient primordial relics from the dawn of the solar system, why are they so wispy and thin? Why didn't Uranus and Neptune get their own vast, dense ring systems? The answer likely lies in the very beginnings of their formation. Saturn, it seems, was born in a sweet spot in the early solar system, a region that was rich in water ice. Its circumplanetary disk, the little nebula from which its moons and rings were born, was likely much more massive and much icier than those that formed around Uranus and Neptune. The ice giants, forming further out in the colder, more desolate regions of space, simply started with less raw material to build with. Their primordial rings were always destined to be more tenuous, more ghost-like. And over the billions of years that followed, these faint rocky rings have been slowly but surely ground down and eroded away. The particles within the rings are not in a perfectly static dance. There are subtle forces at play that cause them to lose energy and spiral inwards, to be eventually consumed by the planet's atmosphere. There is the gentle but persistent pressure of sunlight itself, pushing the smallest dust particles out of the system. The rings we see today are the faint, surviving remnants of what might have once been a slightly grander, but still rocky and dark system. They are the last fading whispers of an ancient song. And what of Jupiter, the king of the planets? Its faint, dusty halo seems to be a different kind of creature altogether. It is not primordial. It is a system in a constant state of renewal, but a renewal of a very different kind. It is a ring of dust, not ice, because its source is the dust of its own small, inner, rocky moons. It is faint because this is a slow and inefficient process. It takes a micrometeorite impact to kick up a small puff of dust, and that dust doesn't linger for long before it spirals into the planet. Jupiter's ring is not a permanent structure, but a dynamic, ever-changing cloud, its density dependent on the random, ongoing process of cosmic sandblasting. So we now see the full picture. The 4 giant planets of our solar system tell 4 different stories of ring creation and evolution. Jupiter wears a temporary, dusty halo, constantly replenished from its rocky moonlets. Uranus and Neptune are adorned with the faint, dark, and ancient threads of their primordial rocky rings, the fading ghosts of the solar system's birth. And Saturn, through a stroke of recent violent luck, has been gifted with a temporary, brilliant, and dazzlingly youthful crown of pure, shattered ice. The difference is not that Saturn is special. The difference is that Saturn is young, or at least its rings are. We are witnessing a fleeting moment of celestial glory, a spectacle that was not there for the dinosaurs, and may not be there for the distant future inhabitants of our world. Section 8. The Shepherd's Quiet Dance. We have explored the grand narratives of the rings, their birth from shattered moons, their ancient origins, their composition of ice and soot. But now we must zoom in. We must look closer at the intricate, breathtaking details within the rings themselves. For the rings are not a simple, uniform disk. They are a place of exquisite and baffling structure. They are filled with sharp edges, dark gaps, delicate braids, and mysterious ripples. They are a celestial work of art, and like any great work of art, they have an artist. But the artists of Saturn's rings are not dramatic or violent. They are small, quiet, and they work their magic through the patient, gentle persuasion of gravity. These are the shepherd moons. Imagine a vast, flat river of orbiting ice particles. Left to themselves, these particles would, over time, begin to spread out. The gentle, random collisions between them would cause the sharp edges of the rings to blur, to diffuse, like a drop of ink in a glass of water. The beautiful, intricate structure we see would slowly fade into a single, blurry, featureless disk. The fact that we see such sharp, well-defined rings and gaps is a profound clue. It tells us that some invisible force is constantly at work, corralling the particles, policing the edges, and maintaining the beautiful order. This is the work of the shepherd moons. These are tiny moons, some no larger than a small city, that orbit within or near the ring system itself. They are the humble, tireless guardians of the ring's structure. Let us watch one of these shepherds at work. Consider the beautiful narrow F-ring of Saturn, a thin, bright thread that lies just outside the main ring system. On either side of this slender river of ice, there is a tiny moon. On the inner edge orbits Prometheus, and on the outer edge, Pandora. These 2 moons are the shepherds of the F-ring, and their dance is one of beautiful gravitational subtlety. Let's focus on Prometheus, the inner shepherd. As it orbits Saturn, it moves slightly faster than the ice particles in the ring just outside of it. As Prometheus approaches a group of ring particles, its own small gravitational field gives them a gentle tug. It pulls them forward, giving them a little extra energy. This boost of energy causes the particles to move into a slightly higher, wider orbit. Now consider Pandora, the outer shepherd. It moves slightly slower than the ring particles just inside of its orbit. As it passes them, its gravity gently tugs them backwards. This slight braking action causes the particles to lose a little energy, and they fall into a slightly lower, tighter orbit. And so this gentle, constant, two-sided gravitational herding goes on orbit after orbit for millions of years. Prometheus, the inner shepherd, tirelessly sweeps up any stray particles that drift too far inwards, nudging them back out. Pandora, the outer shepherd, patiently catches any particles that stray too far outwards, nudging them back in. Together, they act as a gravitational sheepdog, keeping their flock of ice particles confined to a narrow, well-defined path. They are the reason the F-ring exists as a sharp, brilliant thread, instead of a blurry, dissipated cloud. And the dance can be even more complex. As Prometheus dips in and out of the ring on its slightly eccentric orbit, its gravity can create beautiful, scalloped patterns, knots, and braids in the ring's structure, like the wake of a ship passing through still water. This same quiet shepherding is at work throughout the ring system. The great, dark gap in Saturn's rings, the Cassini division, is not empty because there was never anything there. It is kept clean by the constant, resonant gravitational influence of the moon Mimas. Mimas orbits Saturn in a time that is exactly double that of any particle that would be in the gap. This regular, repeating gravitational kick has, over the eons, ejected all the material from this region, creating the vast silent space we see today. Even the broken, arc-like rings of Neptune are a product of this shepherding. The tiny moon Galatea orbits just inside Neptune's Adam's ring, and its gravity is thought to be what corrals the dust particles into those 5 distinct, fragile arcs, preventing them from spreading out into a uniform, complete ring. This is the quiet, patient artistry of the solar system. The grand, majestic structure of the rings is not a static thing. It is a dynamic, living system, constantly being sculpted and maintained by the faintest, most subtle of gravitational whispers. It is a dance between the countless tiny particles of the flock and the quiet, persistent, and humble shepherds who guide them on their eternal circular path. Section 9. A fleeting cosmic spectacle. We have journeyed through the rings, explored their origins in shattered moons, understood their brilliance as a sign of their youth, and witnessed the quiet gravitational artistry of the shepherds that sculpt them. A beautiful and coherent picture has emerged, and it leads us to one final, profound, and somewhat melancholic conclusion. If Saturn's rings are as young as they seem, then they must also be temporary. The peerless, cosmic jewel that we so admire is not an eternal feature of our solar system. It is a fleeting spectacle, a celestial cherry blossom, here for a season and destined one day to fade away. The rings, for all their vastness, are in a constant, losing battle against a host of subtle, inexorable forces. They are being steadily and patiently dismantled, grain by grain, by the very environment in which they live. The first of these destructive forces is the one we have already met: the constant, gentle rain of micrometeorite dust that pervades our solar system. We have seen how this dust pollutes the bright ice, slowly turning its brilliance to a sooty gray. But it does more than that. Each tiny, high-speed impact does not just add a speck of darkness. It can vaporize a small puff of the ice particle it strikes. And more importantly, the impact can knock the particle, or its resulting fragments, out of its stable orbit, sending it on a new path that may eventually lead it out of the ring system altogether. It is a slow, cosmic sandblasting, a relentless process of erosion that is grinding the rings away, particle by particle. But there is a more powerful and more poetic force at work. A process that the scientists of the Cassini mission named ring rain. The rings are not in a perfect, hard vacuum. They are orbiting just above the upper reaches of Saturn's own atmosphere, and they are bathed in the planet's immense magnetic field. And this combination creates a gentle but irresistible pull. Particles in the rings can become electrically charged, either by the ultraviolet light from the sun, or by colliding with the plasma trapped in Saturn's magnetosphere. And once a tiny ice particle has an electrical charge, it is no longer just a subject of gravity. It is now a subject of the planet's magnetic field. The great, invisible lines of magnetic force, which arc from Saturn's poles down to its equator, can now grab hold of these tiny charged ice grains. And so a slow, invisible, and beautiful rain begins to fall, pulled along by the magnetic field lines. These charged particles are lifted out of the flat plane of the rings, and are funneled down into Saturn's upper atmosphere. For millions of years, a steady, silent drizzle of the ring's own substance has been falling onto the planet, a gentle final homecoming for the children of the shattered moon. The Cassini spacecraft was able to directly measure this ring rain, and the numbers were astonishing. The probe found that tons of water are being drained from the rings every single second. At this rate, the entire vast ring system, all of its trillions of tons of ice, will be completely gone in a relatively short cosmic timescale. The current estimates suggest that the rings have, at most, another 100 million years of life left. Let us place this number in perspective. 100 million years sounds like an eternity to a human mind. But in the 4.5 billion year lifespan of our solar system, it is a mere blink of an eye. The dinosaurs, had they possessed telescopes, would have looked up at a Saturn that was plain and unadorned. And any future intelligent species that evolves on Earth, 100 million years from now, will look up at that same plain golden world, with no hint of the magnificent spectacle that once graced its skies. We are, it seems, living in a moment of extraordinary cosmic luck. Our fleeting human existence on this planet happens to coincide with the brief, brilliant middle act of Saturn's great ring drama. We are here for the main event. We are privileged witnesses to a temporary and spectacular beauty, a cosmic artwork that is destined to be erased. This realization adds a new layer of poignant beauty to our view of the rings. They are not just beautiful because they are vast and bright. They are beautiful because they are finite. Section 10. A symphony of creation and decay. And so our long and quiet journey comes full circle. We began with the simple question: why is Saturn so uniquely beautiful? And we have arrived at an answer that is as profound as it is poetic. The peerless jewel of our solar system wears its crown not as a birthright, but as a recent and temporary gift, a glittering memorial to a shattered moon. Its beauty is the beauty of youth, and its fate is to one day fade away into the quiet darkness from which it came. This can feel like a melancholic discovery, a hint of loss in a story of wonder. But let us, in this final chapter, reframe this idea not as an ending, but as the deepest lesson of all. The story of Saturn's rings is a perfect, miniature parable for the nature of the universe itself. The universe is not a static museum, filled with eternal and unchanging exhibits. It is a living, breathing, and ever-changing symphony. It is a story of constant creation and constant gentle decay. The stars themselves are not forever. They are born in the cold, dusty collapse of nebulae. They shine with a brilliant fire for millions or billions of years, and then they too fade, puffing away their outer layers or collapsing into the silent ghosts of white dwarfs and neutron stars. Galaxies, those great cities of stardust, are on immense slow-motion collision courses, their elegant spiral arms destined to be tangled and disrupted into new chaotic shapes over cosmic timescales. The very ground beneath our feet is not solid, but a collection of tectonic plates in a slow, constant dance of creation and subduction. Change is not an exception in the cosmos. It is the only rule. And beauty is not found in permanence, but in the process itself. Saturn's rings are a single, brilliant, and fleeting chord in this grand universal symphony. They are a moment of spectacular, icy creation that has emerged from the chaos, and they will in time dissolve back into the silence. And this is the final, most profound gift of Saturn's rings. They teach us about time itself and our own lucky place within it. We are not just observers of the universe. We are participants, living at a very specific moment. And our moment happens to be the Saturnian moment. We live in a brief cosmic springtime when the most beautiful object in our solar system is in full bloom. We are born into a world where we can look up with our telescopes and see this impossible, ethereal structure in all its glory. Perhaps true beauty requires this fleeting quality. A sunset is beautiful precisely because we know it will fade into night. A cherry blossom is cherished because its delicate bloom lasts for only a few precious days. The very impermanence of these things is what makes them so poignant, so valuable to us. And so it is with Saturn. The knowledge that its rings are temporary does not diminish their grandeur. It enhances it. It transforms our view from one of simple admiration to one of profound, time-bound gratitude. So when you look at an image of Saturn from now on, you are not just seeing a planet. You are seeing a moment. You are seeing the glittering icy echo of a moon that died 100 million years ago. You are seeing a celestial artwork that is slowly, gracefully, being erased by a gentle rain of its own substance. You are seeing a spectacle that exists in a fleeting window of cosmic history, a window that our own species is incredibly, incomprehensibly fortunate to share. The golden world will remain. The great moons will continue their ancient, quiet dance. But the crown will fade. The celestial jewel will dissolve back into the planet. The queen one day will lay down her heavy, beautiful burden and return to a simpler, unadorned state. But for our now, she reigns in all her glory. And we are here to see it. Let this sense of peaceful, grateful wonder be your final thought on our journey tonight. The universe is a place of constant, gentle change, a beautiful and endless cycle of creation and decay. And you are a part of that cycle, a precious and aware moment in the great cosmic story. There is no need to hold on to anything. You can simply appreciate the beauty of this moment right now, the quiet of your room, the comfort of your bed, the gentle rhythmic tide of your own breathing. You are a part of the symphony. And for tonight, the music is soft and slow, a lullaby for a sleeping world. Sleep well and dream of fleeting beautiful things. Good night.